Hello students, in last video we have discussed some concept related to graphics. So in that video we have discussed some introduction part, next ray, beam of light, monochromatic light, composite light, rectilinear propagation, reflection of light, spherical mirror, then types of spherical mirrors, concave mirror and concave mirror, then some parts, then some information about radius of curvature, center of curvature, pole, principal axis, etc. Now we are going to discuss the concept is refraction. So you know the reflection. Reflection means bouncing back of light. The light is travels in say one medium and it turns back to the same medium with a different direction. It is called as reflection. So what is refraction? What is meant by refraction? So refraction means it is obliquely travels from one transparent medium to another transparent medium. That means the light is travels from one medium to another medium. Right? The phenomenon of changing path of the direction. The phenomenon of changing path of the direction as it travels from one medium to another medium. And then the direction of the light beam is changes. The direction of the ray is changes. Right? With the different mediums. In different medium. So, see here, it is refracted ray. It travels from one medium. Here, I am writing, taking the given medium means RAM. So, different mediums are there. Different medium means air medium, water medium, glass medium, diamond, etc. You heard the name of some different mediums in the lower classes, in class 10. So here we are going to taking first medium is rarer medium, next one is denser medium. These two are the different mediums. The light travels from one medium. You know the definition for refraction of light means the light obliquely travels from one transparent medium to another transparent medium, or the phenomenon of changing path as it travels from one medium to another medium. Then one medium in the another medium light travel. So in that time, what changes occurs? What changes occurs? So here it is our medium, rarer medium to denser medium. The light travels from rarer medium to denser medium. It is incident ray, it is refracted ray, this is the normal. The normal is always horizontal to the given surface. This surface is separated two mediums. The surface is separated two mediums, rarer medium and denser medium. So it is a normal. The angle between, you know what we have discussed in the reflection, the normal angle of incident, angle between normal and angle of incident is I, and the normal and angle of refracted rays, that is R. Correct? That is R. So here the light is traveling from rarer medium to denser medium. The light travels from rarer medium. The rarer medium density is less. The light travels to denser medium, and then rarer density is high. When the light is travels from rarer medium to denser medium, the refracted rays move towards the normal. Here, the light is travels from rarer medium to denser medium. ಯಾವಾಗ ಕಡಿಮೆ ಡೆನ್ಸಿಟಿ ಇಂದ ಜಾಸ್ತಿ ಡೆನ್ಸಿಟಿಗೆ ಬರ್ತಾ ಇದೆ ಅವಾಗ ಏನಾಗುತ್ತೆ, the light is move towards the normal. If the light is traveling from vice versa, that means denser medium to rarer medium, the refracted rays move away from the normal. Refracted rays move away from the normal. Illi, when the ray is traveling from rarer medium to denser medium, move towards the normal. If it is traveling from denser medium to rarer medium, it moves away from the normal. Correct? So it is a difference between the light is traveling from rarer medium to denser medium to rarer medium. Then the angle between incident ray and normal is called as incident angle. The angle between refracted ray and normal is called as reflected angle. Refracted angle. Right. So angle through which the direction of change when the light is travels in one direction. On the direction move ಆಗ್ತಾ ಇದೆ ಅದು straight ಆಗಿ move ಆಗ್ತಾ ಇಲ್ಲ. The direction is changes. That changes the changes angle ಇದಕ್ಕೆ ಮತ್ತೆ ಇದಕ್ಕೆ angle change ಆಗೋದಕ್ಕೆ that is called as angle of deviation. ಯಾವಾಗ ಈ straight ಆಗಿ move ಆಗಿರೋ ಅದೇನಾಗಿದೆ it takes changes in the direction. That angle is called as angle of deviation. Angle of deviation. For tensor, angle of deviation d is equal to I minus r. I minus r. Correct. In radar, angle of deviation d is equal to r minus I. R minus I. But we are taking always there is angle of deviation I minus r only. Almost we are using the term, we are using the expression d is equal to I minus r. Okay. Next, we know in the reflection part we have discussed two laws, right? So here also in the refraction it given two laws of refraction. First one is the similar to the reflection of light. So that is say the incident ray, reflected ray, normal, right? Incident ray, reflected ray and normal lies at the same point. ಮೂರು ಕೂಡ ಒಂದೇ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಜಾಯಿನ್ ಆಗುತ್ತೆ. Second one is that is called as Snell's law. That is called as Snell's law. So in Snell's law, it gives a definition. ಒಂದು ಬಂದಿರೋ definition ಗೆ they given the name is Snell's law, right? So according to the Snell's law, the sign of angle of incidence, the ratio of sign of angle of incidence, you know, the ratio is the ratio sign of angle of incidence to the sign of angle of reflection. Correct. Now ratio ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ sign of angle of incidence divides sign of angle of reflection, right? Is constant, that is equal to constant for a given color of light and pair of medium. Pair of medium means it has a two different mediums, arrow medium and tensor medium. So the angle of incidence, sign of angle of incidence, the ratio sign of angle of reflection is equal to constant for a given pair of medium and colors. It mainly depends on the given colors and pair of medium. ಯಾವ medium ಎಲ್ಲ ಇರುತ್ತೆ, ಯಾವ colors ಎಲ್ಲ ಇರುತ್ತೆ. The expression for the n is equal to sin I divided by sin r. Sin I divided by sin r. Where n means that is called as constant. That is called as constant. The constant here refractive index. The constant is called as refractive index. That is one of the value. That is refractive index is equal to sin I divided by sin r. Here two types of refractive index: relative refractive index and absolute refractive index. What is relative refractive index? ಈಗ refractive index ಅಂದ್ರೆ ಗೊತ್ತಾಯ್ತು. That refractive index means constant of the equation. ಅದೆಲ್ಲಿಂದ ಬಂತು? By using Snell's law. Clear? So Snell's law, it is the second law of refraction. It is the second law of refraction. So the Snell's law gives the definition for second law. So ratio of sign of angle of incidence to the sign of angle of reflection is constant for a given color and given pair of medium. So according to that equation, n is equal to sin A divided by sin r. The refractive index, n is refractive index is equal to sin A divided by sin r. The refractive index of the different medium, it is two types of refractive indexes. The refractive index is relative refractive index and absolute refractive index. So first one is relative refractive index. Relative refractive index and the refractive index of the any medium to the refractive index of the other medium, but it is not for vacuum. Vacuum universally relative refractive index ಆಗುದಿಲ್ಲ. It is for normally air, glass, other mediums. ಯಾವುದು air ಇಂದ glass ಗಾಗಿರಬಹುದು, glass ಇಂದ water ಗಾಗಿರಬಹುದು. In this medium we can use the relative refractive index. But absolute refractive index, the refractive index of one medium with respect to vacuum. One medium, any medium, air agirbodu, water agirbodu, glass agirbodu, etc. But to vacuum only, that stage is free. In relative refractive index, both are air or glass or water, any. But there is no vacuum. So that is called as relative refractive index. The refractive index of the any medium with respect to other medium. One refractive index, but another refractive index. So with that is another refractive index is vacuum. That is called as absolute refractive index. Absolute refractive index. Next, we are going to discuss consequences of refraction. Yavadella suitable derivation which examples will give the refractions definitions or terms. We will explain.
Hello students. Previously we have discussed refraction. So you know the refraction means the phenomenon of change in path of light as it travels from one medium to another medium. Yes, you know that. When the ray of light it travels from rarer medium to denser medium, the refracted ray is moved towards the normal. When the ray of light is travels from denser medium to rarer medium, the refracted ray is moved away from the normal. Both the cases we are using in this diagram. So it is uses of refraction. So first consequence due to refraction is that is lateral shift. First one is lateral shift. So in lateral shift we are using one parallel sided glass slab. So parallel sided glass slab, the rays passes through parallel sided glass slab. First one is incident ray, it passes through inside the parallel sided glass slab, that is refracted ray. Then again that refracted ray comes out from the glass slab, that is emergent ray. Here when the ray of light passes through parallel sided glass slab, the direction of the emergent ray as same as the direction of the incident ray, but the ray laterally shifted. This, which one? The refracted ray is laterally shifted with a certain distance, that is x. Now you can imagine there is no glass slab, the incident ray moves in this direction. ಇಲ್ಲಿ ತೋರಿಸಿದಿರಲ್ಲ ಪಾಯಿಂಟೆಡ್ ಆ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಏನಾಯಿತು, that is laterally shifted when the glass slab is placed. So here the distance is x. Then find the value of lateral shift. Here we have total two right angle triangle. One is OPQ and another one is OMP. Right, these two are the right angle triangle. Here the right angle triangle is OPQ, here OPM. So then write using sine function. Sine, you know that the angle between incident ray and normal is called as I, refracted ray and normal is called as R, and here the refracted ray and incident ray, that difference, the refracted ray and incident ray, that is called as angle of deviation. You know the angle of deviation D is equal to I minus R. You can observe here the angle of normal to incident ray. ಯಾವಾಗ ನಮಗೆ ಈ ಲೈನ್ ಸ್ಟ್ರೈಟ್ ಇರಬೇಕಾದ್ರೆ that is incident ray and ಇದು ನಾರ್ಮಲ್ ಆಗಿರುತ್ತೆ. ನಾರ್ಮಲ್ಗೆ ಮತ್ತು ಇನ್ಸಿಡೆಂಟ್ ರೇ ಮಿಡ್ಲ್ ಇರುವ ಆಂಗಲ್ that is I ಮತ್ತು ನಾರ್ಮಲ್ ಮತ್ತು ರಿಫ್ರಾಕ್ಟೆಡ್ ರೇ ಮಿಡ್ಲ್ ಅಲ್ಲಿರುವ ಆಂಗಲ್ R. So that is angle of deviation D is equal to I minus R. Clear? Then write here first sin D is equal to E angle. The sin D is equal to this angle. Sin D is equal to, you know that in sine function opposite side divided by hypotenuse. Which one is the opposite side? Opposite side is, you know that OPQ, that is PQ divided by OP. What is the value of PQ? You know the value of PQ is x and thickness of the given glass slab is T. So write the value of PQ is x and OP, that is sin d is equal to, then write OP is equal to x divided by sin d. You know that value of sin d is equal to sin I minus r. It is equation number 1. Then again, using second right angle triangle OMP, write cos function cos r is equal to. So you know cos r for this right angle triangle, you have the formula for cos r is equal to adjacent divided by hypotenuse. What is the value of adjacent? Hypotenuse is same for both sine and cos, that is OP. What is the hypotenuse? Hypotenuse is equal to OM, this distance OM. You know the value of OM is equal to, that is the thickness of the glass slab. Substitute the value cos r is equal to T divided by OP, then write OP is equal to T divided by cos r, right? Then compare equation 1 and 2, that is x divided by sin I minus r is equal to T divided by cos r, that is x is equal to namigenu beku lateral shift, value of lateral shift, x is lateral shifted, that is x is equal to T into sin, it goes to another side, that means numerator sin I minus r divided by cos r. It is the expression for lateral shift, correct? When the ray of light is incident along the normal, you can imagine when the ray of light is incident along the normal, same angle it passes through. Idiga normal ಮೂಲಕನೇ incident ray pass ಆದರೆ the value of I is equal to 0, and what about the r value also 0. What about x is equal to 0, right? When the ray of light is incident along normal, the value of I is equal to 0, r is equal to 0, lateral shift, x is a substitute value, I, r, everything. So you will get the answer x is equal to 0, right? Then when the ray of light is grazing the surface of the glass slab, when the ray of light incident ray passes here, right? The angle of incident I is equal to 90 degree, clear? Grazing the surface of the glass slab, the angle is equal to 90 degree agutte. So what is the value of r? So the value of x is equal to, substitute, that is t, right? So if I is equal to 90 degree, so their value is x is equal to t. Substitute here, I is equal to, value is 90 degree, then again value of r is equal to 0, then cos 0 is equal to 1, sin 90 is equal to 90 minus 0 means 90, sin 90 is equal to 1 cancel, remaining x is equal to t only. So when the incident ray is incident along the normal, so I value is equal to 0, r is equal to 0, x is equal to 0. When it is 90 degree, x is equal to t, this is maximum possible lateral shift. It is a maximum possible lateral shift, it is a minimum possible lateral shift. It is minimum value of lateral shift, it is a maximum value of lateral shift. Yeah, clear the concept of lateral shift. The final expression for lateral shift, x is equal to t into sin I minus r divided by cos r, right? So now we are going to discuss another concept, is normal shift. So you can take one glass, fill the water, immerse one lemon. ಏನು ಮಾಡಬೇಕು, ನೀವು ಒಂದು ಗ್ಲಾಸ್ ತಗೊಳ್ಳಿ, ಅದಕ್ಕೆ ವಾಟರ್ ಹಾಕಿ ಅದರ ಒಳಗಡೆ ಒಂದು ಲೆಮನ್ ಹಾಕಿ, ನೀವು ಲೆಮನ್ ಹಾಕಿದ ಮೇಲೆ ದ ಪೊಸಿಷನ್ ಆಫ್ ದ ಲೆಮನ್ ಈಸ್ ಬಾಟಮ್, ಎಂಡಲ್ಲಿ ಬಾಟಮಲ್ಲಿ ಇರ್ತದೆ. ಬಟ್ ವೆನ್ ಯು ಹ್ಯಾವ್ ವ್ಯೂ ಫ್ರಮ್ ದ ಅನದರ್ ಮೀಡಿಯಮ್, ನಿಮಗೆ ಗೊತ್ತಿದೆ ಅವಾಗ ಎರಡು ಮೀಡಿಯಮ್ ಆಯಿತು, ಒಂದು ವಾಟರ್ ಮೀಡಿಯಮ್, ಅನದರ್ ಒನ್ ಈಸ್ air medium. You are in air medium, you have to view the object from the side of air, the position of the object it changes, right? So that is called as normal shift. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? When an object O placed in one medium is viewed from another medium along the normal, ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಒಂದು ಆಬ್ಜೆಕ್ಟನ್ನು ಒಂದು ಮೀಡಿಯಮಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ, ವಾಟರ್ ಮೀಡಿಯಮಲ್ಲಿ, ನಾನು ನೋಡ್ತಾ ಇರೋದು ಇನ್ನೊಂದು ಮೀಡಿಯಮ್, ದಟ್ ಈಸ್ ಏರ್ ಮೀಡಿಯಮ್, ವ್ಯೂ ಅಲಾಂಗ್ ನಾರ್ಮಲ್, there is an apparent shift in the position of the object. There is an apparent shift in the position of the object is called as normal shift. Then I will write the values. NO, it is a real position of the object, that is real depth. NI, it is apparent depth, that's a small change ನಮಗೆ ವ್ಯೂ ಎಲ್ಲಿಂದ ಏರ್ ಮೀಡಿಯಮಿಂದ ನೋಡಬೇಕಾದ್ರೆ ದ ಪೊಸಿಷನ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ ಚೇಂಜಸ್, ಸೊ ದ್ಯಾಟ್ change is called as apparent depth, that is V. Then OY, the distance is called as normal shift, that is Y. Then write the formula, n is equal to real depth divided by apparent depth. So n is equal to real depth divided by apparent depth. Now we will write the equation apparent depth is equal to real depth divided by n. Then you know the values for real apparent depth is, we know that apparent depth is V, real depth is U, substitute here, V is equal to U divided by n. Then find the expression for normal shift. So normal shift is IO, right? Normal shift is IO. So write normal shift is equal to distance of real depth minus distance of apparent depth, right? Distance of real depth minus distance of apparent depth, NO minus NI. Then again substitute the value of NO is equal to U. The value of NO is equal to U minus NI is equal to V. You know that NO is equal to U, NI is equal to V. Then value of normal shift Y is equal to U minus U divided by N. How? You know value of V is equal to this one, U divided by n. So U common, write outside, equation Y is equal to U into 1 minus 1 divided by n. It is a final expression for normal shift. Then you know the expression for lateral shift is x is equal to t into sin I minus r divided by cos r. Then expression for normal shift is n is equal to, that is y is equal to u into 1 minus 1 divided by n. It is a final expression for normal shift. These two are the consequences due to refraction, right? It is very easy to understand the concept of refraction. When the object is placed in a rarer medium, when it is passes through denser medium, what is the position of the image, what is the distance of the image, how it is changes, what is the expression, final expression for normal shift, what is the final expression for lateral shift, you have understand. Yes, so it is a expression for normal shift and lateral shift. Yes, thank you.